Math 96, section 8.1. What I did, I have a copy of homework for that sections. So I do have a copy that doesn't have any answers on it. And I'm going to leave a copy of this lecture notes on Canvas for you to see it. So the first problems, they give you two equations. These are first degree equations, and I ask you to verify whether the ordered pair, which is 6, 8, would satisfy these two lines. First of all, equation of a straight line normally is written in two forms. One is y equal mx plus b, and ax plus by equal to c. Equation of a straight line or first degree equations. So these are first degree equations. How do I know they are first degree? Because power of x is 1. Like if I give you an equation which is x2 plus 2x plus 1, this one is not first degree because the power of x is not 1, it's 2. So equation of first degree is always written in these two formats. Example, y equal 2x plus 6, or on this one, 3x minus y equal to 10. When you have an equation like this, y equal mx plus b, m is your slope, and b is y-intercept. Y-intercept is the place that my graph intersect the y-axis. So these are two equations that always are given for straight line. Now, when I have equations like 3x minus y equal to 10, for us to graph equation of a straight line, there are several ways to do it. When equation is written in this form, means x and y both are on one side and c is on the other side, sometimes it's easy to use x and y intercept. X and y intercept means once you put 0 for x and find the value of y, so in that case, when I place 0 here, 0 times 3 is 0. So then I have minus y equal to 10. My c would be 3 times 0 minus y equal to 10, or minus y is 10, or y is negative 10. So they give you a pair of points that is y-intercept because the value of x is 0. We also have x-intercept. X-intercept is when the value of y is 0 and you find the x. In this case, is 3x minus 0 is 10, or 3x is 10. So x is give you a decimal value, which is like 2.3. I'm sorry, 3.3, 2.3. 3.3. Okay. So that's how to graph equation. It is written in this form. Now, we have also another equation, which is 7x minus 4y equal to 10. To graph this, you could also use x and y intercept. When x is 0, this 7x is gone, so minus 4y is 10, or y is minus 10 over 4, or minus 2.5. When y is 0, if I put 0 here, then 7x is 10, and x is 10 over 7. You don't have to use x and y intercept all the time. Sometimes you could use any other number. Like if I go ahead and put x equal 1 here, when I substitute 1, then I have 7 times 1 minus 4y equal to 10, or 7 minus 4y is 10. Negative 4y is negative 7 plus 10, minus 4y is 3, or y is minus 3/4. So you could always substitute any number for x. Sometimes there are numbers that when you substitute for x, it gives you a whole number for y. It's easier to do. So on the first question here, they're giving you a point, which is 6 and 8. They ask you if this point belongs to these equations. In order to verify that, you could take this, if when you have a pair, the first number is always x, and the second number is always a y value. Okay, so you take these two numbers and you substitute for x and y. So in that case, I have 3 times 6 minus 8. I want to see if that is equal to 10 or not. So it would be 18 minus 8 is 10. So yes, 10 is equal to 10. That means this point satisfies the first equations. Now you want to make sure that this point satisfies the second equation too by plugging these two values into this equation. If that's the case, then yes, then you say this is intersection of these 2 points or solution of 2 points. So now the second value is 7 times x, so it would be 7 times 6 minus 4 times 8, and see if that is also equal to 10 or not. So that would be 42 minus 32. And yes, that one also satisfies the equation. So in either case, when I plug this point and plug into the equation, if it works, that means this point belongs to both equations. When you have two straight lines, sometimes to a straight line, they might intersect each other at the point. When they intersect at the point, this point, they call it solution of the equations. Means there is always a point. These are two straight lines. They intersect at the point. This point, they call it solution of a system or solution of two equations. It means coordinates of this point works in either equations. So if you take the coordinates of this and plug into equation of this one, works. And also if you put it into this equation, works. So that's why they call it solution of a system. And now the second problem here, there are two different equations. See, 2x plus 6 and x plus 4 equal to y. So what's the number? Minus 4 and 2. Okay, so we take that minus 4 and 2 and plug here. The first number is always x. The second number is the y value. So I'll take that and substitute here. So it would be minus 4 plus 4 times 2, and that is supposed to be equal to 4. See, you take that and you put into the first equations. So then I have minus 4 plus 8 equal to 4, and then yes, 4 is equal to 4. So that means this point satisfies the first equation. Now we want to see if it satisfies the second equation or not. So you take it and substitute here. So y is 2, and x is negative 4. On the left side, I have 2, but on the right side, I have -2. That means it doesn't work with the second equations. Okay? So it should always work for both equations. So in this case, we say no. This point is not a solution of the system. When we say system, system is combination of two equations. Combination of two equations, or when you have two equations, they call it the system. So this is not solution of this system, or it doesn't work on in both equations. The same thing here. This problem is very similar to that. Number 3. So I have x equals 0 and y equal -3. So I substitute here, and the first equation is 0, -3. See, remember, when you take -3 and you substitute for the y, there is already a negative sign sitting here. So that negative would impact this -3. So outcome is 3 equal to 3. That means this point satisfied the first equation. Let's see if it works on the second equation. You put -3 on here. 2 times 0 minus 3. It's -3 equal to -3. Yes. So this point satisfies both equations. So it is solution of the system. Now we go to problem number 4. Problem number 4, they ask you to graph them. They ask you to graph these two equations. One is x plus y equals 6. One is x minus y equal to 2. Again, the best way to do it is by method of graphing. And remember, when x and y are on one side, it's better to use x and y intercept. Okay, so I can in fact put it here for you. See? To graph the first one, I substitute 0 for x to find the y value. So the first point is 0 and 6, which is this point. They call it x-intercept. So this 0 and 6 is x-intercept. So once you put 0 for x, find the y, or 0 for y and find the x. So the second point, which is y-intercept, is this point. You need to have minimum of 2 points in order to draw your line. So when I find these 2 points and label those on x and y axis, you could connect these 2 points and extend it on either side to find graph of a straight line. So graph of x plus y equals 6 is this. Now the second equation, again, I use the x and y intercept method. Means first I substitute 0 for x. Remember, when you substitute 0 for x, then you have negative y equal to 2. Therefore, y is -2. Be very careful about this negative. Sometimes people think it's positive. No. When you put 0 here, you have negative y equal to 2. So y is -2. And then you put 0 for y, then x is 2. We always recommend to use 3 points to make sure that your line is correct. So if I put another number here, like if I put 1 here for x, then I have 1 minus y equal to 2, or minus y is 2 minus 1, or minus y is 1, or y is -1. So that gives you another point. If you actually find 3 points and all 3 points lie on one straight line, then you know your graph is correct. So on this one, we find another point, which is 1 and -1, which is x is 1 and y is right there. Is right. This is a point of 1 and -1. So again, when you find 3 points and all 3 points fall in one straight line, then you know your graph is correct. So the point of intersections, they call it solution of the system. Point of intersection is solution of the system, which you could easily tell what that point is. X is 4 and y is 2. So if I put x equal 4 and I substitute here for the equations, then y is 2. If I put x equal 4 here on these equations, when I take to the other side is negative, so y is 2. See, they both have 1 point in common. That point is point of intersections. These coordinates of this point exist in both equations, therefore they call it solution of system. The other problem is you have number 5. This is number 5. So you have these 2 equations. One is 2y equal 3x plus 7. The other one is x equal y minus 4. 2 equations, so we get to graph these 2 equations first, all right? 2y equal 3x plus 7 and x equal y minus 4. And we have those here. First, we want to graph this one. X equal y minus 4. I substitute 0 for x, so y is 4. Then I put 0 for y, x is negative 4. And also on this one, I put 0 for x, find the y value, which is 3.5. You put 0 for y, and you find x is 2.3. So when you graph these 2, the point of intersection is 1 and 5. Now, to see if this answer is correct or not, I put 1 and 5 in both equations, and it works. Like on the first one, if I put x equal 1 here, then y is 5. And also on this one, when I put x equal 1, and this one, y is 5. See, they both have these points in common. So that is the point of intersections. When you watch the video, for you to make a note, you could always pause the video and copy the solution. So that would be number 5, and then we go to the next, which is number 6. Number 6 is solve each system graphically. How do I graph equation which is just the x, it doesn't have any y? If there is an equation that has only x in it, x equal 5, what you do is you find that point here, this is 5. I don't see any y on this one, x equal 5. Is not, x equal 5, remember, is a line, is not just the point. Or y equal 1 is not the point, is the line. If you remember that x equal 5 is a line, then you understand that now I need to draw a line. If you draw a line going to point 5 and it's vertical, that gives you the equation. So here, I graph that. x equal 5 is the vertical line. So all the x equal to a number, they all are vertical lines. Now the other one is y equal 1. How do I graph y equal 1? Y equal 1, you on the y-axis, you find 1, and then you draw the horizontal lines. So all the equation that y equal a number, they all are horizontal lines because they don't have any x in it with the red line. So this one is equation of y equal 1. So on the x and y axis, let's just look at another examples. So on the x and y coordinate system, when I ask you to graph x equal -2, how do I graph x equal -2? What you do is on the x-axis, you find -2, okay? And then you draw the vertical line. So all the equation that has x in it, they all are vertical line. What if you have y equal a number, like y equal -7? All the equation that is y equal a number and they have no x on it, on the y-axis, you find -7, and then you draw the horizontal lines. Okay, that's how to graph vertical and horizontal line. And then the next one is the last problems. Sorry, the last problems here. Find it. Number 7, they ask you to graph these two equations. You know, sometimes instead of x and y, we have a and b. So you could use any letter as long as you have two different letters. So now they ask us to graph these two. One equation is 2a plus b equal 9. The other one, a minus b equal to 3. So we are using the same way that we did before. Okay, so here, let's say I want to graph this. 2b plus a equal to 9. So you draw a table again. Instead of x and y, I put a and b. When a is 0, what is the value of y when a is 0? I put 0 here, so 2b is 9, or b is 9.5 or 4.5, which is this point. And when I put 0 for b, 2b is gone, so a is 9, see? And that's the second point here, these 2 points. When you connect it, you have these red lines here. And now the second point is 90044. Again, to be safe, is always recommend to have the third point too. Now I want to graph a minus b equal to 3. A minus b equal to 3. So in that case, again, you draw the table. You put 0 for a, b is -3, which is this point. And then you put 0 for B, and A is 3, which is that point. And when you connect these points, these 2 points, then you have your other lines. And you could see that point of intersections is this point. So if you ask you to read point of intersections, this point, X is 5 and Y is 2. And you could always test it. Let's say if I put 5 here, if I put 5 here for A, and it would be 5 minus B equal to 3, or minus B is equal to minus 5 plus 3, or negative 2. So B is 2. See, that gives you that point. Or also here, if I put 5 for A, then you have 2B plus 5 equal to 9, or 2B is 4, or B is 2. See, that show you that 0.52 works in both the equations. So that would help you to do this first set of the homework for 8.1.